Okay, this is dividing rational expressions, and you can use what you know about simplifying rational expressions when you divide them. And the basics of it is just dividing fractions, which we know we flip the second number and multiply. So our first step is going to factor the numerator and denominator in both expressions. We're going to flip the numerator and denominator in the second expression, cancel out common factors, and simplify if necessary. So on our first one, we have x squared plus 5x plus 6 divided by x, or over x minus 4, and then our division, we're dividing by x plus 3 over x squared minus 2x minus 8. So we need to go ahead and factor, and in the numerator right here, it is my factors of 6 that add up to 5, which is x plus 3 times x plus 2, and there's nothing to factor out in that first expression in the denominator. I'm going to go ahead and change that to multiplication now. So in the numerator, I'm going to put this expression in factored form is x minus 4 times x plus 2. And now in my denominator, I just have x plus 3. In this form, we'll go ahead and state any restrictions. The restrictions will be where this is equal to 0 and this is equal to 0. So x cannot be 4 or negative 3. Now let's cancel anything divided by itself, remember, is 1. And that leaves us with x plus 2 times x plus 2, which can be expressed as the quantity of x plus 2 squared. Okay, number 2. We, again, are dividing. So let's go ahead and remember when we're dividing, when we're simplifying each one by factoring to change it to a multiplication. So I have my factors of 20 with a difference of 8. That's going to be x plus 10 times the quantity of x minus 2. In the denominator here, the only thing I can do is factor out a GCF of x. Change it to multiplication. There's nothing to factor in the second expression, so I'm just going to change it by flipping. Go ahead and state your domain restrictions. Right here, we know x cannot be 0. Here, x cannot be negative 10. And here, x cannot be 2. Now cancel out anything. Anything that's divided by itself is always 1. And that leaves us with nothing left, so we know our answer is just going to be 1. All right, let's go on to the second part. On page 2, we have problem number 3. And here we're again going to factor and change it to a multiplication problem. Right here, we'll use the A&M method. When we do that, we get 2x plus 3 times x minus 1. Denominator, that's a difference of two squares, perfect squared, separated by a minus sign. So I take the square root of each term, and I'm using different signs. Numerator right here, we're going to move to the denominator. This is going to now be on top, and that is x plus 3 times x plus 3. And the 2x squared minus 7x minus 15, again we'll use the A&M method to factor it, gives us 2x plus 3 times x minus 5. Alright, state our domain restrictions. None of these can equal 0. That means x cannot be positive or negative 3. Here it cannot be negative 3 halves. And here it cannot be 5. Cancel out anything divided by itself, remember, is 1. And that's going to leave us x minus 1 times x plus 3 over x minus 3 times x minus 5. Number 4, here, the only kind of factoring we're going to be doing here is GCF. Cannot do anything with this numerator. Right down here, I'm going to take out a 5. Change it to a multiplication, so I'll be taking out a 10 right here as common to both terms, leaving me a plus 1 over a. I'll state my restrictions. A cannot be negative 1 or 0. And now cancel out anything that is the same. And we have a plus 1 and a plus 1, and that simplifies to 10. One last example here. Numerator, we're going to factor here. That's, again, the difference of two squares. Denominator, I need to factor out an x first, and then I will use my A&M method. And what I would suggest doing is to go ahead and stop or pause the video, make sure you've got the factoring down, and then come back and check it. Right here, I'm going to flip this so that my numerator is my denominator, denominator is my numerator. The only thing I can take out that's common there is the x. And then it's over x minus 3. Domain restrictions, nothing in the denominator can be 0. Right here, that would be negative 2/5. And that's negative 3. That's going to be positive 3, so I can just write it as positive or negative 3. Let's cancel out anything divided by itself is 1. X plus 3 and x plus 3, and x minus 3 and x minus 3. Nothing is left over, so our simplified version will just be 1.